So we were solving radical equations and inequalities yesterday. That's what we're going to continue to do today. And then tomorrow we're going to review the whole chapter. And then on Friday, take a chapter or a unit test, everything in chapter 6. It's a lot of stuff. I did revise my steps on solving a radical equation, which was the majority of this worksheet. So I don't know if you guys saw the video or not, but here it is. Step 1 is to isolate the radical. Okay, you got to get the radical by itself. Step 2 is get rid of the radical. How? By applying an exponent on both sides of the equation. So what do I mean by this? Get rid of the radical by applying an exponent on both sides of the equation. If you have a cube root, you're going to have to get rid of the cube root by applying the power of 3. If you have a fifth root, you're going to have to get rid of the fifth root by applying the power of 5. So whatever radical you have, whether it's square root, third root, whatever type of root you have, you're going to apply that exponent to get rid of that root, and you do it to both sides. And of course, step 3 is check your answer. So go ahead and pick any equation on this worksheet that you might have struggled with. Or do you guys want to do like an easy one, then a medium size? 13? Okay, let's take a look at 13. So step one, according to our steps up here, is to isolate the radical. So as you can see, the radical is on the left side of the equal sign. It's definitely not by itself. So we're going to isolate it by getting rid of that minus 1. You get rid of a minus 1 by doing the opposite, plus 1. What you do to one side, you do to the other. And here's your new radical equation. The square root of 8n minus 5 equals 3. If you take a look at step 2, it says get rid of the radical by applying an exponent to both sides. Now, because this is a square root, we're going to get rid of the square root by applying the power of 2. Does that make sense? If I had a third root right here, I'd be applying the power of 3 and the power of 3. If I had a fourth root, I'd do the power of 4 and the power of 4. Because it's a square root, I want to be applying the power of 2. And what I do to one side, I do to the other. Apply the power of 2. That'll get rid of the square root. So the square root and the square eliminate themselves. This is what you have left over, 8n minus 5. And 3 squared is 9. So it becomes a nice simple equation. Then you just solve it the way you normally would. And you end up with 8n equals 14. Divide by 8 on both sides, you get n equals 14 divided by 8. Of course, you could reduce 7 over 4. Better answer. Now, we need to double check it, right? And when you double check, it might even be easier to not reduce it, because if you plug in 14 over 8 right here, think about that. Think about the n being 14 over 8. Then the 8 and the 8 would cancel out, and you'd have 14 minus 5, which is 9, and you'd have the square root of 9, which is 3, and then 3 minus 1 would give you the 2 that's there. So that's what we call double checking, where you plug it back in. I didn't show my work. Should I show my work plugging it back in? No? Jumping to number 17, we have step 1, which is isolate the radical. That's what it says right here. Step 1, isolate the radical. Now, if you don't see a radical, it's the same thing as a rational exponent, right? A rational exponent is a radical. We need to isolate this rational exponent term, or isolate this radical. This is really a square root. So we need to get this by itself on the left side of the equal sign. We don't want this minus 6. So step 1 is to get that by itself by getting rid of the minus 6 by doing the opposite. What do we have now? We have the isolated radical, 3g plus 1 to the 1/2 power, which is really the same thing as the square root of 3g plus 1. Now, what does step 2 say? Back here, step 2 says get rid of the radical by applying an exponent to both sides. So we need to get rid of that square root by applying what power to both sides? 2, right? And you don't even have to change it to a square root. You could leave it like that, put parentheses around it, put a 2 right there, and put a 2 over here. Now, why is that? Because we know that a power to a power you multiply, and 1/2 times 2, that would cancel itself out. That would become 2 over 2, which is just 1, right? The 2, when you multiply, cancels with that, and you end up with no more exponents, just the exponent of 1. So you end up with 3g plus 1 equals 100. And then you solve like you always would. You end up with 3g equaling 99, which means g equals, when you divide both sides by 3, 33. And you should plug it back in to double check it. When you plug in 33 right here, 3 times 33 is 99, plus 1 is 100. The square root of 100 is 10. 10 minus 6 really is 4. So once again, if you follow these steps, any radical equation or any equation with a rational exponent will be really easy to do. Isolate the radical or isolate the rational equation term. Once you isolate it, get rid of it. How? By applying a exponent to both sides of the equation. So if you have a third root, apply the power of 3. The fifth root, apply the power of 5. That'll get rid of it. And don't forget to check your answer. Any other ones on the first half? 19? A lot of people freak out when they see square roots on both sides. But step 1, isolate the radical. Well, this radical is already by itself. This radical is already by itself. So there's really nothing to do. Step 2 is to get rid of the radical by applying a power, by applying an exponent. What power are we going to apply to both sides? Yep. And that magically makes them disappear. Two d minus 5 equals d minus 1. That just becomes a regular algebra 1 equation. Subtract d, subtract d. You end up with the regular d minus 5 equals negative 1 plus 5 plus 5. D equals 4. Ta-da. But don't forget to double check, right? Take that value of 4, plug it in right here to the original. Ignore the 2's, go to the original. Plug in 4 right there. 2 times 4 is 8. 8 minus 5 is 3, so we get the square root of 3 on this side. Plug in 4 right here. 4 minus 1 is also 3. The square root of 3 is going to equal the square root of 3, so they are equal to each other. So it does work, so the answer is 4. What do you guys think? Should we try one more, or should we just move on to the inequalities? Move on to the inequalities? Okay, so we know these steps to solving radical equations. Again, let me reiterate. Step 1, get that radical by itself. Step 2, get rid of the radical by applying a power. And then after that, check your answer. Inequalities, we're talking about an area of answers. So when we solve inequalities, it's really doing two problems in one. And step 1 is to look inside the radical if it's an even root. Okay, if it's an even root, you look at the inside of the radical and you set it to be greater than or equal to 0. Again, only if you have an even root. If you have a square root, a fourth root, a sixth root, an eighth root, you have to take the inside value of the radical and set it equal to 0 and then solve, and that'll be one answer. And then step 2, solve the entire inequality the way you normally would a radical equation. And then you get 2 answers, and then step 3, check those 2 answers, which is an area of answers, not just actual values. So let's take a look at, I don't know, pick one, 23 through 28. 25. Okay, so the question is this an even root?
Yes.
Yes. Because it's an even root, I need this to be positive. I need this to be greater than or equal to 0. So that's one problem that I need to solve in itself. I need 2q to be greater than or equal to 0. And I need to solve that. Okay? When I solve it, divide by 2, divide by 2, q is greater than or equal to 0. There's one answer. Right? Now let's do the other answer. How do we do the other answer? By just looking at the whole thing and solving it like if it were a radical equation. So step 1 on a radical equation is to isolate the radical. So I need to get rid of this 8. What would I do? Subtract 8. That's right, subtract 8. What you do to one side, you do to the other side. Your radical equation is now the square root of 2q is less than or equal to negative 3. What's the next step after you isolated the radical? To get rid of the radical by applying a power. What power am I going to apply to both sides? 2. What I do to one side, I do to the other side. What do I have left? I have 2q is less than or equal to positive 9. Final step would be divide by 2, divide by 2. By the way, when we're solving inequalities, if I were to divide by a negative 2, I'd have to flip the inequality symbol. I haven't done any examples like that, but just remember on inequalities, on the last step, if you multiply or divide by a negative, you have to flip the inequality symbol. I don't need to flip it right now because I'm dividing by positive 2. But there's my answer. Q is less than or equal to 4.5, or you could leave it 9/2. It'll make it easier when you test your values. Okay, so what we should do after getting those two answers is do a quick sketch of a number line, and let's put the answer 0 right here, and let's put the 9/2, which is 4.5, over here, and let's represent the inequalities that are stated in our answers. It says Q is greater than or equal to 0. Greater than or equal to is that way. And then over here it says Q is less than or equal to 4.5 or 9/2. So less than or equal to is this way. So as you can see, we have an area that is together between the 0 and the 9/2. So I need to write my answer as a compound inequality written together. So how do I do that? I put the smaller number on the left. Whoops. Smaller number on the left. Bigger number, 9/2, on the right. I put the x in the middle, and I put the inequality symbols less than or equal to on both of those. So here's my answer that's represented up there. Now you should, just to feel more confident, you should test values. Now what do I mean by test values? You could pick a number that's in here and it should work. So you can pick any number you want. Let's pick a nice number. A nice number to plug in right here would be the number 2. That would be nice. Because 2 times 2 is 4. The square root of 4 is 2. 8 plus 2 is 10. And, whoa. And 10 is not less than or equal to 5. So that didn't work, did it? Or did I do something wrong?
No, in the back it says no solution.
Okay, good. So yeah, here's a great example of why you need to test values, right? When I tested the number 2, I plugged it in right here, and it says 2 times 2, which gives me 4, and the square root of 4 is 2, and 8 plus 2 is 10, and 10 is not less than or equal to 5. So I know that my answer should have been here, but it didn't work. Weird. Now, if you tried other values, like if you plugged in any negative number to see if there's answers on this side, if you plug in any negative number, that would give you a negative value that would make it imaginary, so none of these work either. And if you plugged in any bigger number over here on this side, if it's no solution, it's not going to work either. So just for fun, let's plug in a big number, let's say 12. No, not 12. Let's say 8. Why 8? Because 2 times 8 is 16, and the square root of 16 is 4, and 8 plus 4 is not less than or equal to 5. So none of the areas work. So this is a special case where it's no solution. So even though we got these two answers, when I tested my answers, none of them worked. So it would be a no solution problem. So be very careful with that. Any other ones on that last section? $27? All right, this will be the last one. So it's kind of like, on inequalities, it's kind of like solving two problems if you have an even root. If it were the third root, you just solve it and get one answer and it'll be an inequality answer. But if you have an even root, you need to make sure that this is what?
Equals to 0?
Greater than or equal to 0, right? Greater than or equal to 0. Yeah, you need to make sure that this is positive. So if you write c plus 4 has to be positive, which means greater than or equal to 0. And if you were to solve it, you're going to get c is greater than or equal to negative 4. If you subtract 4 on both sides. Okay, so this is one answer. Let's go back to the entire inequality and solve the whole thing like if it were a rational equation or a radical equation. So I need to isolate this first. What do I need to get rid of? The 9. So I want to subtract 9. Subtract 9. I want to end up with negative square root of c plus 4 is less than or equal to what?
Negative 3.
Negative 3. Now, what's my next step here? It's still not isolated because I have a negative out here in the front. So what do I do?
So divide the negative 1.
Divide by negative 1 or multiply both sides by negative 1. I want to divide both sides by negative 1. Now, this is an inequality, and because I'm multiplying or dividing by a negative, I must flip my inequality symbol. So what do I have left? I have the square root of c plus 4, but I need to flip this symbol to become greater than or equal to, and then the negative 3 divided by negative 1, that's positive 3. So far, I have isolated the radical. Next step would be to get rid of that radical by applying a power to both sides. What power am I going to apply? That's right, 2. So my new inequality will be c plus 4, no more square root, is greater than or equal to 9. Subtract 4, c is greater than or equal to 5. So I have our two answers here. C is greater than or equal to negative 4, c is greater than or equal to 5. Now, when we think of the area of answers, because we still need a test, just in case we end up with no solution like that other one, here's our number line. We have negative 4 over here. We have positive 5 over here. And when I look at this one, c is greater than or equal to negative 4. Greater than or equal to is to the right. And when I look at this one, c is greater than or equal to 5. It's also to the right. So this is not an area that's together. So I'm not even saying that my answers are right here. The overlap piece will be over here. They're both pointing in this direction, so the overlap piece is right here. So my best guess is that the answers are over here at 5 or greater than 5. Okay? It's not an area that's in between the two because the areas are not together. But the overlap is over here, so my guess is that my answer will be x is greater than or equal to 5. But of course, let's test some answers just in case it's an extraneous answer and we have no solution here. So if you were to test any number that's greater than 5, and you could even use 5, right? But any number greater than 5, what would be nice to plug in right here that's greater than 5 that'll make it a perfect square number? 12, all right? So if I plug in 12, let's go to the original actually. Plug in 12, 12 plus 4 is 16, square root of 16 is 4, 9 minus 4 is 5, and 5 is definitely less than or equal to 6. So this is a true statement. All of these are my answers, so this is my single answer. If I were to try any number in here, it would not work. Like, look, let me show you. Let's test the number 0, which is clearly in between negative 4 and 5. When I pick 0, 0 plus 4 is 4, square root of 4 is 2, 9 minus 2 is 7, and 7 is not less than or equal to 6. So you see how 0 did not work? If I were to plug in any further negative number, it would not work either. Let's say I plugged in negative 10. Negative 10 plus 4, that's a negative number. You can't do the square root of a negative. It becomes imaginary. So any value, any negative number over here is not going to work either. The only area that works is over here. Therefore, this is the only answer that you get. Make sense? Okay, so the test Friday, since we didn't have a single quiz on this section itself, this is going to be the biggest part of the test. So think of it, the test Friday is going to have a lot of this stuff plus a little bit of everything we did in the first part of chapter 6. All right? And of course, we're going to review tomorrow. But today we're going to spend one more day on solving radical equations and inequalities.